So what does this unlock for us? Well, ideally, we'd like to front load all the declaration emit, preferably all in parallel if you have the hardware, but anyway, we can increase the amount of parallelism we have. So basically, we want to go from this situation to this situation. Right, the green boxes are all at the beginning, declaration emit finishes, and then how many cores you have, you can take advantage of all of them. And hopefully, the time that you see there is the time that we can spend not actually waiting for TypeScript anymore. Hi everyone, my name is Titian Cernicova-Dragomir. I'm a software engineer in Bloomberg in their JavaScript infrastructure team, and I'm also a TypeScript compiler contributor. And today I'd like to talk about the feature that I've been working on and off for about the last year and a half. So we're going to talk about exactly what isolated declaration is. We're going to talk about the motivation behind the feature, at least for us. And we're also going to talk about how we worked on this feature and what work there's still left to do, and maybe, how you guys can get involved if you want to help. So what is isolated declarations? It's a new feature in TypeScript 5.5. It's basically a new flag that you can enable. And what happens is that it forces you to use less inference on definitions that actually make it into the declaration file. So basically, it's going to add squiggly lines to everywhere where the type checker and inference would be needed. So you might be asking why. I like inference. Quite frankly, so do I. The point is that you could emit these declaration files with only the information that you actually find inside that file. Right? You shouldn't need the type checker to actually perform the emit. And you already saw in the previous presentation how OXC is actually using this to emit declaration files without actually duplicating the whole type checker. And that's actually part of the point. What was the motivation for us, more specifically? Well, we all know TypeScript compilation can be slow. I think that's something that everybody kind of complains about. And that's especially true if you have a large monorepo with many projects. Now, we at Bloomberg, we have an internal build tool that does use the compiler, the TypeScript compiler API to build our source code. And this tool tries to run as many type checkers as possible in parallel in the hope that it will finish faster. And that only works so far. Turns out that we can't actually run a lot of things in parallel. Now, you might be surprised to hear that. Why would that be? I mean, we've got plenty of hardware on our laptops, so why can't we just spin up as many TypeScript compilers as we have cores? Well, the answer is that it's not always that simple. So for example, we have a sample monorepo that we used as a test throughout developing isolated declarations that had 23 projects in it. Now, it turns out that at most, we can type check 4 of them in parallel. Why is that? Well, the problem is that projects in a monorepo usually end up depending on each other. That's kind of one of the things that you want to do if you have a monorepo. And if you have, for example, a very deep dependency graph, well, then you can't really start to build app until all of your dependencies have finished building, right? So that's a problem, right? So basically, if you want to think about how the time diagram for that build would look like, it would look something like this. Notice that at most 2 projects get to type check in parallel. And that's not great, right? We want to be able to run more things in parallel. We have a lot of hardware. We have a lot of hardware in our CI. Why do we have to wait for the dependencies? To understand how we could actually make things better, we first have to look a little bit at what TypeScript actually does. TypeScript does 3 things. It does type checking, does declaration emit, and it does JavaScript emit. Now, there have been various efforts to duplicate type checking, and maybe somebody will crack that nut in the future and we'll have a Rust version of type checking. But until then, I'd like to not have to rewrite the whole type checker. Generally, type checking should still be just up to TypeScript. The 2 other parts, however, are outsourceable to some degree, right? The problem with declaration emit is that right now, well, before this feature, it depended on the type checker. So you couldn't really rip out declaration emit because you still needed information from the checker. So in each one of your builds, basically all of these 3 things are happening in sequence. Now, when TypeScript communicates between the projects in a monorepo, the way it does it is actually through declaration files. So what you need from the build, it's not a type checking. You don't care about the type checking to unblock dependency to your dependent projects. You just care about those declaration files. And if we can get those declaration files before type checking is complete, well, that would be a way to unblock the type checking for the dependent projects. Now, you'll notice that JavaScript emit is kind of its own little lonely bubble in there without any arrow going to it. And that's because JavaScript emit is already pretty independent and has been for a while. So, some tools already emit JavaScript from TypeScript today, and this has been happening for quite a while. That's mostly due to a flag that was added a while ago called isolated modules, which will add squiggly lines if you're using features of TypeScript that another tool cannot replicate without the type checker. So basically, we thought of this new flag, isolatedDeclarations, as being analogous, right? It will put squiggly lines if you still have a dependency between the declaration emit and type checking. So what does this unlock for us? Well, ideally, we'd like to front load all the declaration emit and then unblock type checking for all the other projects preferably all in parallel if you have the hardware, but anyway, we can increase the amount of parallelism we have. So basically, we want to go from this situation to this situation, right? The green boxes are all at the beginning, the declaration emit finishes, and then how many cores you have, you can take advantage of all of them. And hopefully, the time that you see there is the time that we can spend not actually waiting for TypeScript anymore. But again, we can only do this if declaration emit does not actually depend on type checking. Now, turns out we were not the only ones to have this issue. Google also had the same problem. And actually, the issue that opened up this project was opened by somebody at Google. And we started collaborating together with them and also with Microsoft to actually bring this feature into TypeScript. So what did we start with? Well, the first thing we tried to do is we could try to prove that we can actually generate the same output without the type checker, at least in the cases where the types were present. So we built a standalone declaration emitter, sort of as a reference. And this was completely cut off from the type checker. But it did reuse the AST and the declaration emit part of TypeScript, right? Just we cut out the type checker. In parallel with this, we also tried to find a set of basic inference rules, and that could be implemented in this mode. Now, you might be thinking, didn't I say that inference was bad? Isn't that kind of the thing that will stop us from emitting declarations? Well, yes, but developer experience is still something important if we want people to use this feature. And without any inference, things could be pretty painful. So I'm going to preempt sort of a question that I know everybody's going to ask, like, do I have to add type annotations to everything now? And the answer is no, I assure you don't. I also love inference. It's a great tool. I don't want to have to annotate everything. It's opt-in, right? And unlike other TypeScript features, for example, like strict null checks or strict in general, it's not viral, right? You don't have to enable it just because your dependencies enable it. You only have to enable it if you have a monorepo or a composite project where you want to take advantage of the parallelism and speed up your builds in this way. So can we do some inference in this mode? And so we went through like 3 iterations. So level 0 was no inference. And we're going to see why that is probably a bad idea in just a few, in the next slide. The next one we said, well, let's do some trivial inference. And the last version was optimistic inference, which we explored, but for now it's not included, and we're going to see exactly why. So what does level 0 no inference look like? Well, you'd have to write annotations for everything, right? So you're assigning a number literal, you still have to say its number. For consts, it's even worse. You basically have to duplicate the same type in the assignment and in the type. Not great. Even worse for things like an object literal where you're as consting it, right? That type is not anything, not something somebody would actually want to do. For functions that you assign, for variables that you assign functions to them, well, you'd have to duplicate the whole function signature in the type as well. And for fields, it would basically be the same. So definitely not something I would want to write with. Definitely not something I would want to go to my colleagues with and tell them, this is the way we're writing TypeScript now. I fear there might be riots. So it's not what we did. We said, okay, starting from this, which ones of these can we trivially infer? Right, and the first one is pretty obvious, like for primitive literals. Sure, I mean, for assigning a number to a mutable variable, TypeScript is going to infer number. That's unlikely to change, and it's pretty simple for somebody else to implement without duplicating the 60,000 line type checker. So we don't really need that. For const, similarly. And that also works for fields. Read-only fields would also probably be literal types. So that works out nicely. Also from objects, right? If we have an object literal, as long as it only contains other primitive literals and contains other supported kinds of inference, again, we can probably do away with this type and not have people actually write this. And for functions or function-like expressions like methods or and arrow functions, right? Again, well, it's pretty trivial to just copy the parameter list to the new signature. It's not something that is that difficult, so we don't need this type. People will still have to write the return type, unfortunately, because we can't easily determine the return type without the type checker. But, that's not that horrible. So, this was the first level we thought of. And by the way, I want to point out that these are not the only inference rules. They're just some samples I have. We also infer from non-const object literals, from array literals. So there's a whole suite of things that you can actually infer from even if you are in isolated declarations mode, because they're simple enough for somebody to implement. So can we add more inference? Can we do more? And for a while we thought maybe we can. The main problem is that TypeScript type checker is actually very, very smart. Like I said, it's a 60,000 line file in TypeScript called checker.ts. Asking everybody to re-implement that would not be something that would go down well. So we want to keep our emitters dumb and hopefully pretty fast. And we don't want the emitters to have to look up information in other files. So given these constraints, we started thinking, well, maybe we can make some guesses that are mostly true. So what happens is that we could let an external tool emit a declaration file. And if TypeScript then type checks and sees, oh, this particular instance could not correctly be inferred by an external type checker, it would then emit an error in just that case. So let's look at some of these examples, and I'm just going to show some examples where people usually look at them and say, well, why can't you do this? I'm going to show that that would actually be an example of optimistic inference, and we're going to talk about why we didn't actually do this in a few slides. So the first example is, well, if you have a variable and you're not assigning another variable to it, everybody who's delved into a little bit of advanced TypeScript types might be familiar with the typeof operator in the type system. You can say, well, the type is the same as the type of the variable we're assigning, right? That seems reasonable. Unfortunately, it's only sometimes true, right? If horizontal is defined as a variable that is of type string, then yes, the type of horizontal is going to be the same as the inferred type of orientation. They're both strings. That's wonderful. However, if horizontal is defined as a const variable and as a literal type, it's just the type, the string horizontal, well, then we have a problem because TypeScript widens the type on assignment. So type of horizontal is not going to be the same as type of orientation. One is going to be the string literal horizontal, and the other one is going to be string. So this kind of inference would be wrong depending on the definition of the target variable. What about something like this? And this one is, again, very requested. Right? We can see that we're just newing up a new class. Why can't we just say, well, it's the same type as that constructor? And again, we can't do this because it won't be always true. If it's a class, then yes, this is going to be true. It works well enough. It's going to be map of string and number. However, in TypeScript, you can define a random variable and type it as a constructor signature. And this particular constructor signature is returning an instance of some totally unrelated class. Let's call it M. Right? So now the type of our variable is going to be actually M of string. It looks nothing like the constructor from which it came. Right? So for the common case, it would work, but what about the uncommon case? So this will be wrong depending on the definition of that constructor. And the last one I'm going to look at And again, I want to stress that these are not the only three we actually considered while we were doing this. There were plenty of others. But computed properties, right? This looks simple enough. And let's say we could infer this type for that variable, right? We're just using n as a computed property, but in the type space. And again, this works as long as that variable is defined as being something of a literal type, right? So n is going to have the type string n. And TypeScript normally would infer an object type with name in there. It would expand that property. But using the computed property is close enough, right? These two types are basically equivalent, so that's fine. The problem is that if n is a string, well, then TypeScript would actually infer a string index signature for that particular object literal. So we can't, and the worst part is that if we try to use n in a type position, we actually get an error in the declaration file, right? So we're producing invalid declaration files if we use n in a type. So again, this one will be wrong depending on the definition of the variable that is used as the computed property name. So all of these three cases I think are pretty common, and people generally would like to be able to write these without having to add annotations. Unfortunately, we can't always infer the type without the type checker. So why did we ultimately reject this? So we can be optimistic, but obviously we would not always get it right. So TypeScript would need to come back and sort of clean up after us. And the errors would be kind of hard to understand. It would have to be something like this type that is inferred in isolated declarations is different from the other type that would be inferred otherwise. I don't think TypeScript needs more confusing errors. Has enough of them already. So yeah. And the second problem is that just by looking at the file, you couldn't determine if it can be emitted without the type checker, right? So if the annotation is missing, it's pretty clear that that file is not compliant with isolated declarations. Well, in these cases, you can just by looking at the file determine if it is compliant with isolated declarations, if somebody actually checked that file and if it is okay to emit declarations. And some of the tools that tool builders that we talked to actually said that they needed this to make their tools work. Now, doesn't mean that all of the cases I showed you before are off the table. For example, we are actively looking into bringing back computed properties. Maybe some changes in TypeScript could make this inference not optimistic. I don't know. We will see. Somebody from the TypeScript team is actually looking into this right now. But in the meantime, how can we make things easier? Well, if you have an isolated declaration error, the easiest way to fix it is to just insert the type of the variable or the field that is that isolated declaration is complaining about. But your language service can help with this. If you have your IDE open and you have this error, TypeScript already knows what the type of that variable should be. So what we did is we created a quick fix where you can just go insert the type for that and fix my isolated declaration error. And this is actually the method we use to convert that monorepo that I talked about in the beginning to work with isolated declarations. So it's pretty good. It probably doesn't always generate the type that you would manually write. It does generate the type that would end up in declaration files, so those types would have been generated before anyway. It's just that we're bringing that step up a little bit closer to development time. I want to give a special thanks to Hannah Ju at Google, who worked on this quick fix extensively, and most of this is her work. So we worked at this for a while now. We were pretty happy with it, and we just wanted to see exactly how fast can this new approach get us. And we wrote a separate tool to actually build all of the TypeScript projects in parallel from our monorepo. And we were pretty happy with our initial results. We tested two approaches: the parallel topological build, where you wait for dependencies, and the parallel isolate declarations build, where you don't wait for dependencies. And if you compare those two, you actually see that you get a big win, like 33 seconds versus 22 seconds. That's a decent win. However, it turns out that our true competition was not the parallel version. It was TypeScript -B, right? So -B is the composite project support in TypeScript. You can build monorepos with it. And that actually turns out to be a lot faster, right, than we expected. It takes 27.9 seconds to build that particular project, at least on my machine, right? So the win is still smaller. Interestingly, the parallel topological case is actually slower somehow. And this wasn't a great laptop. It's my personal my corp laptop. It's overheats, but it's a decent laptop. We were doing this with 6 workers. So the question is, how is TypeScript -b so fast? I mean, it's single-threaded. TypeScript doesn't do multi-threading in its compiler. So we were basically using 5 extra cores to get 20% slower when we're doing to the topological case, and get 20% faster with isolated declarations, which, I'm not gonna lie, was disappointing. I mean, you work for at something for 6 months, you expect a little bit more than 20% win. Turns out that TypeScript actually has a very clever trick up its sleeve. Namely, if you bring in a file, and that file is used across multiple projects, TypeScript will cache the parsing of that file. So it'll keep it in memory, and it will reuse it across all your projects. And this is especially beneficial for declaration files, right? Because those same declaration files usually end up being used in probably all of your projects. So we went back to our tool, and we also added a ASD cache, source file cache per worker. Now that will still result in some duplicate work because we can't share objects between workers in JavaScript, at least not yet, hopefully at some moment in the future. But still, that is less duplicate work than we were doing before, right? TypeScript -b would do the parsing only once. We're going to do it once per worker. So let's see if that actually makes a difference. So the parallel topological case, the one where we wait for dependencies, at least it's faster now. We're using 5 extra cores to get 8%. Not great, but hey, at least we're not slower anymore. However, the isolated declarations case actually did gain a lot. It was 40% faster. I think that's a pretty good improvement. And with this, we tried it on other systems as well. For example, our Linux CI system has 72 cores. We also tried on some MacBook laptops. And what we consistently saw is that just doing, throwing cores at type checking doesn't necessarily help by a lot. Sure, it does help, but since you end up doing a lot of duplicate work, it's not going to be as powerful as you expected. However, with isolated declarations, we can see that the wins are much greater. If I think a bar chart is more illustrative, and because in some cases it's 3 times, we end up getting the build 3 times faster. So, I think that's a pretty cool win. So, what do we have in TypeScript at the moment, and what can you actually use? Well, in TypeScript 5.5, we merged the flag for isolated declarations. So this ensures that with this flag turned on, an external tool could, in principle, emit those declaration files. Right? There would be no need to go back to the type checker for the information. Right? We even have a few people who implemented, and you already saw the TypeScript itself implements a version of this. We also have OXC as the previous speaker talked about, and SWC, right? So there's some excitement and some people working with this, which I find quite exciting. So what do we still want to do? Well, right now, we don't actually have a good reference declaration emitter in TypeScript. The one that is in there, sure, it doesn't use the type checker, but it's not completely divorced from it. It could still potentially use it. It shouldn't, but this means that it's hard to actually prove that the set of rules we have to kind of when we're showing you the squiggly lines is actually correct, right? And we did have a reference emitter in the project when we started out. Like I said, that's the first thing we built. However, that duplicated a lot of code in TypeScript, so it wasn't merged because it would create sort of maintenance nightmares in the future. So what we're doing now is we're actually working to refactor some of the TypeScript code to actually take out some of the components that are in the type checker, for example, so that we can use them in this standalone declaration emit that other people could look to as a reference. We're also looking to improve developer experience where possible. Like I said, computer property names are an active area where we're investigating. And we're always open to other improvements based on feedback. And I guess this is where I want to sort of have a call to actions for everyone here. What can you do to help with this feature? Well, if you're developing a build tool, see how you can take advantage of this extra parallelism. See if you can actually speed up your type checking, launching the type checker in parallel and taking advantage of the fact that now you can do this without having to wait for declaration files. and let us know how it goes. What problems will you encounter? And if you're just writing TypeScript, well, turn on the flag. Tell us what are the biggest pain points. What do you see as something that would stop you from adopting this feature? And report all of your findings on the TypeScript GitHub repo. That's where we can have discussions about this, and you will find tickets specifically dedicated to the status of this feature. And you can comment there, or if you find a bug, you can also open a new issue. I want to give a special thanks to everybody who was involved. Like I said, it was involved an effort from multiple people at multiple companies, both from Google and Microsoft and my colleagues at Bloomberg. So we're all really happy that this feature is finally coming, and we hope we hope that in the future it will actually have an impact on everybody's build if you're using a monorepo. So thank you very much.
Do you cache TypeScript declaration files for unchanged packages?
We didn't focus much on things like the incremental aspect of this. So most the times I quoted there are all for clean builds. The tool that we built for like the power, we're not interested in necessarily building a tool that does this for production. We didn't open source that part specifically because it was more just as a proof of concept. So those times that you saw are just clean declaration, clean build times, nothing incremental.
Nice. Is inferring types from a validator like Zod or archetype without complex annotations off the table for projects wanting to adopt this?
That's a difficult question. It's a question I get asked very, very often. I don't think it's completely off the table because, like you saw, we can infer types from literals and object literals. The API design that Zod currently uses, where it chains methods, that's off the table. That's not going to work with isolated declarations. I'm not even sure it works great with current TypeScript because that kind of ends up with a long chain of things that need to be typed. But if you were to create an object literal where you're defining your schema, nothing's stopping you from going, give me the type. I'm going to create a new type based on the type of that constant using typeof. And that is the type that's written. It's compliant with isolated declarations. You're still going to map it to something different. But it's about API design. It's how you're going to design that API that does the validation. So it's not off the table, but not with current API designs, I think.
Got it. We got time for maybe one more. Is the lack of isolated checking what kills Rust compilation speed? And is there a way to implement this optimization for Rust?
I mean, I don't know. I'm not a Rust person. I have some vague understanding of Rust, but it's not my area of expertise. So unfortunately, I cannot really speak to that. Maybe somebody else who works with Rust can speak to that. But yeah, it would be interesting. I don't think it's just a TypeScript only problem, but it definitely was a very big bottleneck from what we saw in our own TypeScript projects.
Awesome. Well, we will end it there. Thank you so much. Continue the conversation in the chat. And thank you, Titian. Give him a round of applause.